Okay, ladies and gentlemen, you are welcome. So in this video, we are going to look at solution to some of the questions in heat capacity and specific heat capacity. So question 1 here says, what amount of heat in joules is required to raise the temperature of copper by 8 degrees centigrade, given its specific heat capacity is approximately 400 joule per kilogram per Kelvin? So I think, ladies and gentlemen, this is simple. The first thing to do here is to bring the data from the question. And remember, when you set specific heat capacity, it means it's the amount of heat needed or required to raise the temperature of 1 kilogram of a substance by 1 degree centigrade. So let's see, you have an object here. Let's see, you have an object E, and the mass of this object is 1 kilogram. So the amount of heat that is required, to raise the temperature of this object or of this body by 1 degree centigrade, is what we call specific heat capacity. So it means that, ladies and gentlemen, at this point when we are talking about heat capacity or specific heat capacity, it is talking about the exact mass of the object as 1 kilogram. So it's the amount of the temperature, or it's the amount of heat that is needed to raise the temperature of an object of 1 kilogram by 1 degree centigrade. So let's say the initial temperature of this object, let's say, is 5 degrees centigrade. So when you now add heat to this object E, let's say the temperature still maintain object A, so the temperature becomes 6 degrees centigrade. So that is actually what we mean with specific heat capacity. That is the amount of heat that is required to raise the temperature of an object of 1 kilogram by 1 degree centigrade is what we call specific heat capacity. And we have a formula that relates the quantity of heat that is required to raise the temperature of the object, which is Q, is equal to mc delta T, or we can say delta T. The M here, the Q here stand for quantity of heat. The Q here stand for quantity of heat. That is one. And then the next one, of course, is M, which is the mass of the objects. And then the C here stand for specific heat capacity. And then we have delta T. The delta T here stand for change in temperature. Change in temperature. We stand as delta T is equal to theta 2 minus theta 1. So this is actually the formula for calculating specific heat capacity. So now the next thing, ladies and gentlemen, is to answer this question. So you see, the question is asking, what is the amount of heat that is required to raise the temperature of copper by 0 degrees centigrade? So I think this is simple. So we are now going to say now the quantity of heat Q now is unknown. That is what we want to get. So we need to bring the data out. And then after this, the Q, then we are also given the temperature. So the temperature here is, I think something is missing in this question. Let me look at it very well. Okay, to raise the temperature of 0.5 kilogram, to raise the temperature of 0.5 kilogram of copper. 0.5 kilogram of copper. So therefore the mass here is 0.5 kg, and then the change in temperature here is given as 8 degrees centigrade. And of course the specific heat capacity is given as 400 joule per kilogram per Kelvin. So what are we going to do now? So we are now going to calculate the Q. So how do we get the Q? We take this formula. So we now have Q is equal to MC delta theta. And of course, we already have M. So we now have Q is equal to the M is 0.5, and then the C is 400, and then this change in T is 8. So what do we do now? This is now the same thing as 1600 joules. So this is the answer for this question, ladies and gentlemen. So let's look at another question. Okay, so ladies and gentlemen, we have example 2 here, which says a 2.0 kilogram aluminum cube's temperature rises from 20 degrees centigrade to 60 degrees centigrade. When left in the sunlight, how much energy in joules, how much energy in joules was transformed into the cube, given aluminum specific heat capacity is 900 joule per kilogram per degree centigrade. So I think this question is also very simple. So what are we going to do now is to bring the data. So now the data is that we are starting with mass. M is given as 2 kilogram. And then of course the temperature rises from, so we have our theta 1 as 20 degrees centigrade, and then we have our theta 2 as 60 degrees centigrade. And then of course the specific heat capacity is given as C is given as 900 joule per kilogram per degree centigrade. So what are we going to do is now we are now going to take the formula. Of course, the question is asking how much energy in joule. So it means that Q is unknown. So the formula for calculating this, we are now going to say Q is equal to MC delta theta. And then the Q is now equals to M is 2 times specific capacity 900, and then the change in temperature here is 60 minus 20. So therefore we now have Q is equal to 2 times 900 times 40, and this will give us 72,000 joule. So this is actually the answer for this question too. So ladies and gentlemen, don't forget to subscribe, follow, and join my YouTube community for more videos, and see you next. Thank you. Bye bye.